In order to understand the tangent function, you have to understand the tangent line. That is the line that only touches the circle at one exact point. It does not bisect it, it does not go through it, it does not avoid it. Exactly touches it at one point. In fact, not only it touches a circle, it touches any curve at one point. Any line that touches any curve at one point can be called a tangent. This can also be extended to higher dimensions, such as there can be a tangent plane onto a sphere, which touches the sphere also at one point only. So the tangent function plots the length of a section of the tangent line. Now, what section? The section that comes from the point that it touches the circle to the point that it touches the radius. Now, if the radius itself does not reach out of the circle, there's no such point. But let us extend the radius as far as we have to, and then it will touch the tangent at some point. The length change achieved this way will be the tangent function. Here, this plots the tangent as the time is passing. Notice that even though it looks like the speed is varying and it's slow in the middle and then it speeds up, there's no actual speed change in the speed the circle is going around. There's no angular velocity change there. But the length of the tangent line that we're plotting is not changing linearly. So that's why you see this weird motion that looks like you suddenly slow down and then you speed up again. Also notice that the tangent is discontinuous. When the radius is parallel to the tangent line, there is no function plotted. There's an asymptote, and I assume you are familiar with asymptotes. As an exercise, you can try to figure out how many radians you have to go to find an asymptote, how many radians you have to go to find the 0 point, and why. And as a little help, I'll tell you that the tangent can be thought of as sine over cosine, and the cotangent could be cosine over sine. The third and probably hardest to visualize function is the secant. Same thing as the tangent. Look at what the secant means. The secant line is any line that goes through the cycle. It cuts it. Section comes from cutting. So we extend the radius out until it reaches the tangent line. And the length of the extended radius from the center to the tangent line is going to be the secant. And the change of its length as a function of angle is going to be known as the secant. The animation might be a little fast or a little confusing, but all you have to do is realize that its minimum value is 1 when it exactly touches the tangent line. The maximum value is infinity when the radius is parallel to the tangent. The animation contains 2 lines because it's trying to show both the tangent and the secant line. So now you have all the trigonometric functions defined in a circle. Now there's one thing left, specifically to connect the wave to the triangle, because both of these objects have been connected to the circle. The only thing you need is the third connection, the wave and the triangle. And this clip, I think, makes it clearer than I can make it in words. What basically happens is the angle in the triangle is changing as the circle is going around, and the change is plotted out in a wave.